Hi everyone, welcome to my video presentation for SIGCSE 2020. I'll be talking to you about equity and drag and drop programming. So the paper I did was an analysis of a large-scale motivational survey for middle school students. First of all, I wanted to say I'm really sad to not be at SIGCSE. It's always a lot of fun. I love being there, but this is just really not the year. So anyway, without any further ado, let me share my presentation. Perfect. So yeah, my name is Jeffrey Bush. I am a researcher, PhD candidate, and instructor at the University of Colorado Boulder. My research sort of strand falls in two domains, one in middle school computer science education and the other in formative assessment and using technology to support math teachers. You can follow me on Twitter at Bush_Jeff. I'll have tweeted out these slides as well as a link to this video. So you can follow along with the slideshow, and yeah, anyway, feel free to message me or tweet at me if you have questions or anything you'd like to talk to about the paper. I'm excited to engage with people, and I think that seems like a good medium, well, as good of a medium as possible with me not being able to attend the conference. All right, so first of all, I would like to thank my co-authors. I could not have done this paper without them. Monica Gilmore is a colleague of mine at the University of Colorado here in Boulder, and Susan Miller, former colleague of mine from the University of Colorado, is now the Associate Superintendent of the Archdiocese of New York. So this paper came about, we first started working on it about 5 years ago, and Susan and I found some things in the data and started putting this together, and then Monica jumped on board to help with some of the framing and conceptual framework piece. So anyway, thank you to both of them. They've been wonderful editors and super supportive, and again, this could not be possible without them. All right, so I'm going to start at the end. That's how I like to do presentations, right? Why do you care? What's the big deal with this paper? I'm going to start with that, and then I'll backpedal a little bit, talk about methodologies and background before diving into the nitty-gritty details. So why do you care, right? What we found is that middle school students with prior drag and drop programming experience have higher motivational outcomes. This is great news, right? Awesome, right? The CS for all thing, it's doing good. So that's great news, right? We've got sort of good news, but it's mixed with some bad news. The bad news is that this boost in motivation is not equitably distributed. So groups that are traditionally underrepresented in, historically, underrepresented in STEM and computer science in particular are seeing a lower boost from this prior experience. So prior experience is already right at the middle school level working to have an inequitable, give an inequitable advantage and help students who are already ahead across the board get ahead even more. So we're gonna talk a little bit at the end about why that is and what some suggestions are, as well as how we came to that conclusion. All right, so before we dive in, I want to make sure we're all on the same page about what I mean by equity. Some of you may have seen the infographic with the sort of baseball game and 3 people watching them. I like this one a little bit better because, right, we're talking about learning and how we're not trying to provide the exact same experience for all students. We're trying to provide the same outcome, right? And certain curriculum don't necessarily fit for some students. It can fit for some students who've already had success, but we want to make sure that we have opportunities that are available to everyone so everyone can take up those opportunities and be successful, right? We need to have the right size bike for everyone to ride. We need to have the right curriculum and right opportunities to have everyone getting interested and engaged in computer science early on, not just, okay, if this model of gaming and hacking and being sort of a hacker, modder, remixing in the context of competition in games, if that works for you, great. And if it doesn't, well, the bike doesn't fit and you're gonna have to find somewhere else to get interested, right? That's not what we want. What we want is computer science is a broad field. We wanna find ways for everyone to get engaged early on, right? So that's what I mean by equity, and equity in terms of opportunity and allowing to make sure that there's experiences that work for everyone in the classroom. All right, so I'm sure we all know, right, about the pervasive opportunity gaps going on in computer science. So here we see employees at top tech companies, right? Historically, we see underrepresented minorities. By that, I mean Black, Hispanic, and non-Asian, non-white ethnicities being underrepresented. The field is dominated by people with those racial identities, and then it also tends to be disproportionately male as well. So unlike sort of the general population, the field is more white, more Asian, and more male than the United States as a whole, or than the globe as a whole. So that's something that we're trying to fix, right? Throughout this paper, I talk about underrepresented minorities, URM, and generally what I mean by that is students who identify on a survey as being not white and not Asian. So this is an issue, right? We've got a leaky pipeline across STEM, where you get lots of students graduating from or coming in as ninth graders, and then some drop out, and we've got high school graduates, and they keep dropping out. And by the end, there's not very much left for STEM and computer science. It's an even smaller bit of that. So what we're trying to do is we're trying to fix some of those leaks, right? When do students drop out? When does their motivation lead them to not pursue computer science? And motivation early on can start to view yourself as, oh yeah, I see myself as capable. I see myself as a computer scientist, and computer science is something that is interesting to me, seems relevant in the world. And those motivational factors early on can lead to identity development and help fix leaks all the way throughout this pipeline that we see here. So CS for All is an initiative that was started by the Obama administration. And the idea was we want to get computer science in all classrooms, right? The amount of funding that they were hoping to get didn't end up going through Congress, but you did have a big push of, okay, we want to get computer science everywhere. It's also been a priority, or at least a claimed priority of the Trump administration. So, right, the United States government is prioritizing wanting to get computer science in the classrooms for all students. And this idea is if we get computer science experiences early for everyone, they're going to be more likely to get interested and engaged, and when they go to college, they're not going to already feel like they're behind from the students who took computer classes as electives, or we're in the computer club after school programs, right? We're trying to make access to computer science less privileged and something that can happen for everyone. So this is a big push, and the idea was we want early experiences. And what we're looking at in this paper is great, early experiences, that's good, but what kind of experiences are students having, and what are the effects of those experiences? Because if it's not the right experience, maybe it's not going to be as helpful as we think. So drag and drop programming is a really popular technique for early students, middle school students getting engaged and hooked with programming, right? It's got tons of advantages that are known. I'm not trying to say drag and drop programming is bad. It really helps with, you remove some of the syntax errors, and it's got a lower floor to entry, but it still has a really high ceiling in terms of being able to build really advanced programs. So we've got Scratch, right? It's probably the most popular one. We also have Alice that looks at 3D, and then the Scalable Game Design Project has Agent Sheets, which has now been replaced by Agent Cubes as a 3D environment, as also a popular one, especially here in Colorado. So, and these all came about, they've got their own history, and anyway, you can ask me if you want to know more about the history of how these all are sort of interconnected and go back historically. And anyway, they're similar, different, but similar. But what we did in this paper is we're trying to look at, do students have prior experience with these programming languages? And if they do, how does that differ from students who don't have prior experience with those programming languages? And then within the students who have prior experience, what differences do we observe? So that's kind of the big picture for the study design. We have a huge sample size. We had a survey with 17,000 middle school students. So this was through the Scalable Game Design Project where I used to work. And prior to participating, they took a motivational survey. The sample was eventually cleaned down to just under 10,000 students. That's because, we're only looking at middle school. We're only looking at students who filled out all the questions. And right, data cleaning took out a lot of students, but we still have a huge sample, almost 10,000. Even the other studies with big survey results, right? This is big scale. So just wanted to reiterate that, because it really helps with the validity of the study, showing that it's not just a survey we did with 200 kids or even 1,000 kids, it's 10,000 students. So we've got a lot going on there. We asked them about their prior experience. Do you have prior experience with Scratch, with Alice, with Agent Cubes, with Agent Sheets, right? What have you done before was one of the questions on this survey before they participate. And then we asked them about motivational outcomes, which I'll talk to. I've got some slides on that coming up. Finally, the end of the survey, we asked about demographic info. So what's your self-reported ethnicity? We used ethnicity, sort of the way that the US Census talks about it. And then we took those results and we categorized students as being an underrepresented minority in computer science or not. So basically, are you Asian or male? Then you're not a URM. Or sorry, are you Asian or white? Then you're not a URM. And if you don't identify with either of those ethnic groups, then you are considered, for this study, underrepresented in STEM. We also look at self-reported gender. For this study, to simplify things, we assumed gender is a binary construct. I know that it's much more complicated than that, but from a quantitative research standpoint, we made that assumption early on. And anyway, so that helped simplify some of our analysis. We also asked students a couple background questions. The ones that we kept that were particularly interesting were, do you have a computer at home? Which we used as a proxy for okay, sorry for the break. We had a microphone issue, but it seems to be back online. Perfect. All right. So we were talking about our study design with the survey. We also asked students what language is spoken at home, whether it's English or Spanish or some other language, right? And we ended up using these in our analysis. So I said I'd talk about motivational outcomes. We ended up doing a factor analysis, which if you're interested in going into the weeds on that, there's a lot of information in the paper about what we did and how we created these motivational constructs. I'm not going to go into it in this presentation because it's really technical, but and this is a computer science conference, not a measurement and evaluation research conference. But anyway, feel free to reach out to me if you have questions on how we did this. Basically, we looked at, of all of these 17 questions that students answered relating to motivational outcomes, which ones that they answered, if they answer, I'm interested in the work I do in this class, are they also more likely to say I enjoy the work, or that computer programming is fun, or that I want to take classes where I design games, right? So these things all were clustered together and created a factor where we said, okay, all of these items, they are associated, responses are associated with one another. And when we read them all, they all seem about general interest, right? Are you in general interested in this class? Computer programming is boring, which we reverse coded, was later removed because it was found to be redundant with computer programming is fun. We did use that as a test for if students say, yes, computer programming is fun, strongly agree, and computer programming is boring, strongly agree. They probably were just saying, strongly agree to everything, and we threw them out. We had about 100 students who did that. So it was a nice little test to see if students were authentically taking the survey. So these were the general interest. This is one of our primary constructs. The next one is their future interest in computer science. This one I think is one of the biggest, most important ones that we have. Saying I want to take a class where I design games. That one was in both factors. But also I'd like to take another computer programming class, or I want to study computers in college, right? Computer scientists have fun jobs. I enjoy talking to people about computers. I want to design games at home. Are you interested in pursuing computer science in the future, right? It's not in this class, it's beyond in your life, which as a middle school student can go a long way. If students become more interested in computer science in the future, that's really gonna help. So this was a big one. We also had programming confidence, which was only one really item after the computer programming is not hard was removed. We just were left with computer programming is easy. Confidence was important, but we only really had one question that mapped onto this construct. And then lastly, we have general confidence, and this is about computing, general confidence about computing. So using computers is easy. I'm confident in my ability to use them. I'm good at solving computer problems, right? Understand what's being talked about in class. These were computer science classes. So this is just our students generally confident about their ability to use computers. So these are our 4 outcomes. We have 4 outcomes for this study, which helps, right? Gives us a lot to talk about. Also want to say that we had a diverse sample of students. So here we can see pretty similar between those who had, just under 5,000 students who had prior experience and just under 5,000 who didn't, which really, again, helps with the validity. And of those, our demographic representation is pretty similar across the board. Also, this demographic information is pretty close to the demographic information of the U.S. It's slightly more Hispanic and Latinx than the United States as a whole, and which makes sense, right? Coming from the West, in an urban area in the Western United States, and also it had significantly higher Native American population than the United States as a whole by about 10x, right? There's 1% of the United States on the 2010 census identifies as being Native American. We had about 10%. That's because Scalable Game Design does specifically does some work on reservations in the West. So we had more representation from that group, but otherwise it was pretty representative sort of sample looking at the United States as a whole. So we had 4 outcomes, right? General interest, future interest, programming confidence, and general confidence, and we built a regression model. So in that regression model, if you're familiar with regression, this equation at the top might be interesting. If you're not, again, let me know. I'd be happy to talk you through it. But we're looking at what's the quote-unquote effect, and right, we're taking this lightly because it's an associate. Right, is there association between these two things? And we know the correlation isn't causation, but we're controlling for a lot of factors, and we're anyway trying to look at, okay, I think it's helpful to think of this as an effect and then take that effect with a grain of salt. Otherwise, the terminology with it gets pretty verbose. So what's the effect of prior experience for each of these subgroups, right? What is the experience for underrepresented minorities who are male and female, and non-underrepresented minorities who are male and female? Is prior experience having a boost, providing a different boost to different groups? We're also controlling for if you have a computer at home, do you speak Spanish at home, or do you speak another non-Spanish, non-English language at home? So we have some controls that we're looking at, which is really helpful in sort of suggesting that there might be a cause between, okay, is this prior experience causing some of these motivational differences? So here are our results, right? And we're going to focus on one of these at a time, starting with general interest. So if any of you are parents of teenagers, you can probably, or middle school students, you can probably attest to this. Students tend to not be as excited about things that they are currently doing. And so it's not super surprising that just your general interest for this didn't really change if you've done it before. Oh, I've done agent cubes before. I'm not that excited to do it again, right? Or I've done Scratch before. Okay, yeah, we're going to do it again. We see that white and Asian male students are a little bit, barely statistically significant, but it is. It's a 0.05 with 1 star. It's barely statistically significant, but they're a little bit more excited. It's 0.05 as far as an effect size, standardized difference, so it's a very small gain. And we see a small and similarly statistically significant decrease in excitement for female underrepresented minorities. So this is a bit of an issue. Why is it that female students who are underrepresented in STEM demographically show up less interested? Oh yeah, I did Scratch last year. I'm less excited to do it. That's 0.1 as a standardized difference. So it's starting to be noticeable, right? They're less interested in participating in this class. So that's a problem. That's something that that should be an alarm, concerning, and leads us to think about what types of experiences are these students having, and how can we change them to make them more engaging, more interesting, help students see themselves in STEM and get excited in the future to do it again. All right, moving on, we've got programming confidence, computer science interest in the future, and these have similar results to one another. In general, all these bars are positive. Everybody's getting a boost. This is helpful, right? If you do one of these drag and drop programming experiences, you're going to show up more motivated, right? More confident in your ability to program, and more interested in computer science in the future. That's great, right? It's good news. The bad news within this is that if you are white and Asian, that association is higher. If you are male, that association is higher, and they double, right? So it's each one, it leads to a higher boost. We've got more, that's true with confidence, but also with future interest, which I think is the most consequential of these outcomes. already at middle school. In middle school, we're seeing students who are demographically overrepresented in STEM getting more interested in doing this in the future. So these experiences, this leads us to think that these experiences are creating biases as early as middle school towards some students wanting to participate and other students not seeing themselves in the future comfortable participating or excited about participating in that. General confidence, it's more of a sort of general positive across the board, which is good. You've done this before, you're more confident to do it again. Differences between the groups are not significant here. So in general, it's good, sort of medium-high associations with, okay, great, I can do this again, done it before, I can work with computers, solve problems with computers. So that's some good news. All right, so we've got some takeaways, right? All groups have higher confidence and future interest after drag and drop programming experiences. So that's great, right? Some good news. Bad news, this increase is higher for white and Asian males than their programming, for their programming confidence and future interest, right? So that's an issue because, right, we want to be providing things that are exciting for everyone and equally exciting for everyone, if not more exciting for students who need more support given the institutional and cultural factors that are already working at play. So URMs and females have lower boost in confidence and future interest in computer science and drag and drop programming experience. This is doubled for female underrepresented minorities. So there's some cause for concern here that I think will hopefully draw attention to what is it that we can do, right? What works for equity in computer science. So I'm going to end with some suggestions and some takeaways. What can we do about this to help? What do we know about equity that we need to change? We need to make sure that in middle school, right, we're avoiding relying too heavily on the gamer and hacker context. This is something that smaller scale studies have done, and now we're seeing at a big scale. A lot of these curriculum rely heavily on gamer contexts, and it doesn't seem to be working for equity, right? So let's avoid that. If we do use those, there's some studies that suggest that sportsmanship can be a really nice way to bring in more students into this context of gaming. Storytelling is also really helpful. So helping others, finding a way to think about computing instead of as competition, as a way to help one another, and do good in the world, that's really helpful. Giving students agency is also really helpful. So design a story with your game, or design a game. If you're going to do games, design one that has a context that relates to your life. I know you like animals and you want to take care of an animal. You're going to make a simulation about taking care of an animal. Because where you live, right, I talked to a student before that said, I'm designing a game about this because where I live, we can't have a dog. I've always wanted a dog. So I'm going to make a simulation about taking care of a dog. That's great, right? It lets them bring in their out-of-school interests and their out-of-school lives into the computer science classroom. And then also music and artistic connections with computer science, right? There's a huge field there that can be really helpful for equity. So anyway, big takeaways, right? Drag and drop in middle school experiences are often helpful for motivation and interest, but right, we really need to pay attention to the curricular dimensions of those experiences to make sure that they're designed with affordances to be taken up equitably and not perpetuate institutionalized inequities. Wonderful. Well, thank you. Thank you for watching. Again, you can follow me on Twitter or just look me up on Twitter. I'll have these slides as well as this video, and I'd be happy to answer any questions that you all have. Enjoy the rest of your SIGCSE experience.